Good morning.
Good morning, sir.
Start. A small correction in the previous on thing which we have discussed. The correction is nothing but this power is equal to 2 pi nt mean by 60. But in this expression, we'll substitute t in Newton meter only. Newton meter. Okay. But generally, how it will be is you will give the power, you will give the speed, and the t what we will get from this expression we will be getting in Newton meter. Later on in our expression, t by j is equal to tau by r is equal to g theta by L. We'll convert t, for example, say some 50 kilonewton meter is what we got from this expression 2 pi t by 60. Then what we'll do, we'll t is equal to 50 into 10 power 3 into 10 power 3, which was in Newton meter, now Newton mm, which is equal to mute your mic, Ritesh. Ritesh. So T, which was what we obtained in Newton meter, for example, 50 kilonewton meter, we have to convert into Newton mm, 50 into 10 power 3 into 10 power 3, which is nothing but 10, this 10 power 3, this mm will cancel, or I can write T is equal to 50 into 10 power 6 Newton mm. Generally, what we will get from this expression is in Newton meter. In RPM, T in Newton meter, and power in watts. In some authors will write 60,000, then it should be P should be in kilowatt. No need to confuse that. We'll keep in watts only. 60. Okay. Now there are some. There's a. We need to compare. Uh, we need to compare our solid shaft and the hollow shaft for strength, stiffness, weight, and other things. Which one is better? We need to look into that. But you should know that for all the purposes, for all the purposes, let me give you an example. See, when I consider a solid shaft like this, we know that maximum shear stress is at the outer fiber, isn't it? This is where the maximum shear stress is. This is where, like this. But this material here, this region of material is just a waste. There was no need of this material. The maximum stress is here. If I have the material at this region only, it's more than sufficient. So generally, wherever there's a maximum stress, that is maximum stress is at outer fiber. Therefore, if we have the material like hollow shaft, it will suffice our need because there is no stresses man, no stresses are there is a very minimum stresses at the inner fiber. That is when you come towards the center point, there is very minimum or low stresses, but the maximum stresses at outer fiber. Let us make the material to be only at the outer fiber. Let the material be only at the outer fiber, then we can have the maximum stresses. Then maximum stresses will be there here at this fiber, and there is no need of material here. We are saving the material, we are saving the cost, and also this shaft is able to withstand more torque, it has more stiffness, lesser weight, and other things. We'll look into that. We need to prove it. That is how we have to understand this region. What is there in this region? We don't require material because this is subject to very minimum stresses. Maximum stresses is at the outer fiber here. Then why the material is required here? Let us remove that material. Then we require the material only this thickness. That is why your propeller shaft and the shafts will be made are generally hollow. I have seen propeller shaft of trucks. It is hollow. It is not solid. It is hollow in nature. Okay, because it has a higher suction modulus. Okay, T by G is equal to tau by R or J by R suction modulus is high. Let us have the material at the outer fiber so that the maximum stresses I can have. So I can accompany for maximum stress. I can accompany for torsional strength. I can accompany for angle of twist. I can accompany for weight. All these things can be reduced by using hollow shaft. Okay, hope you can understand that. We will derive now. Next. Testing. Comparison of torsional strength of hollow and solid shaft. We are comparing the torsional strength of hollow and solid shaft. Now you should give in the examination explicitly. Compare the torsional strength for solid and hollow shaft. Okay, for the same material, length and weight, something like that. You should give. Okay. Now, all right. Consider a hollow shaft and solid shaft of the same material. Length will be same. Length and weight. So length and weight. Okay. So in this torsional strength in the sense, this is T by tau, right? We remember torsional strength in the sense T by tau. Same material, this G remains the same, L remains the same, weight. Let us write, weight is the parameter. Weight of hollow shaft is equal to weight of solid shaft. Weight of hollow shaft is equal to weight of solid shaft. Okay. Now, uh, we know that density is equal, let me write, density is equal to mass by volume. Specific weight, specific weight or specific density, which is nothing but weight mg by volume. You will read study in your fluid mechanics. Specific weight is equal to mg by volume. Instead of mass, I am having into g, which becomes w. Okay. Instead of this, I can write rho, which is equal to w by specific weight is equal to weight by volume. Density was mass by volume, weight by volume. If I multiply rho into V is equal to my weight. Okay. Density is mass per unit volume. Specific density or specific weight is weight per unit volume. This is therefore weight in the sense gravity comes into picture into G by volume, which is rho V into W. Okay. Volume, if I consider a shaft like this is the area of cross section A. Volume will be equal to this A into this L, isn't it? A into L is the volume. If I multiply this area, if I take this area and if I multiply throughout by this length, I will get the volume. Okay. Specific weight is equal to rho into V into W. Okay. According to our this thing, weight of hollow shaft should be equal to weight of solid shaft. Okay. Weight is nothing but this is rho V, rho V, rho V of hollow should be equal to rho V of solid. Okay. This rho into rho into area of hollow shaft into length of hollow shaft is equal to rho into volume of solid shaft. Sorry, area of solid shaft into length of solid shaft. He has given length of both the material is same and the material is also same. Both the materials are for example from steel. Specific weight cancels out. Therefore, we are left with area of hollow shaft is equal to area of solid shaft. This is how we come. Next, area of hollow shaft is equal to area of solid shaft. Area is given by pi d square by pi d naught for 4 by di for 4. Sorry, pi d naught square 4 di square by pi d square by 4 is pi d naught square minus di square by 4, which is equal to pi d square by 4 is the area of solid shaft. Pi by 4 cancels. Or d square, which is equal to d naught square minus di square. Or d square, which is equal to d naught square take common, d naught square minus di by d naught the whole square. d square which is equal to d naught square into, sorry, d naught square is 1 1 minus k square, where k is equal to di by d naught, or d is equal to d naught root 1 minus k square. I will call this as 1. Okay. Next, yes, say, yes, given, compare the comparison of torsional strength of hollow and solid shaft. Let us say torsional strength, torsional strength is given by T, let us write T by J is equal to tau by R is equal to G theta by L, or T by tau is the torsional strength, T by tau which is equal to J by R, T by tau which is equal to J by R, or torsional strength, torsional strength of hollow shaft, hollow shaft by torsional strength of solid shaft, which is equal to J by R hollow by J by R solid. Next, let me write J by torsional strength of hollow shaft, which is equal to J by, this is J by R in the sense, J by R in the sense, this outermost fiber we should take, isn't it? Z by P, J by R, this is R naught, outermost fiber. J by R naught, this is J by R naught. For solid shaft, this is J by R. Okay, this is where tau is maximum. J by R naught, which is equal to pi d naught power 4 minus di power 4 by 32 by d naught by 2, which is equal to pi d naught power 4 minus di power 4 by 32 into 2 by d naught, a torsional strength of hollow shaft which is equal to pi by 16 d naught power 4 minus di power 4 by d naught power 4 by di power 4 by d naught. Okay. Next, torsional strength of solid shaft, which is nothing but J by R of solid shaft, which is equal to, I'll write it here, which is equal to pi d power 4 by 32 by R is equal to d by 2, which is equal to pi d power 4 by 32 into 2 by d, which is equal to pi d cube by 16. Okay, pi d cube to 16 by d cube by 16. Therefore, torsional strength of hollow shaft by torsional strength of solid shaft, which is equal to, many slides I have skipped. Let me write. I'll write it here. Torsional strength of solid shaft, which is equal to J by R, J by R, which is equal to pi d power 4 by 32 by d by 2. Outermost radius is the outermost fiber is a point where maximum stresses are induced. Pi d power 4 by 32 into 2 by d, which is equal to pi d cube by 16. Torsional strength of hollow shaft by torsional strength of solid shaft, which is equal to pi by 16, right? Pi by 16 d naught power 4 minus di power 4 di power 4 by d naught by pi by 16 dq. This cancels, or which is equal to d naught power 4 minus di power 4 by d naught. This is 1, d naught, d naught, sorry, d naught dq. Torsional strength of solid shaft by torsional strength of solid shaft, which is equal to d naught power 4. I will take common d naught power 4 into 1 minus di by d naught raised power 4 by d naught into dq, which is equal to d naught cube into 1 minus k power 4 divided by d cube. What we got d cube? D cube, it was d naught root 1 minus k square. D is equal to d naught root 1 minus k square from 1. Therefore, torsional strength of hollow, torsional strength of solid shaft, which is equal to, instead of d, I will substitute this term. D is equal to d naught cube, d naught cube. Root is equal to half, right? Root is equal to half. Whole cube in the sense 3 by 2. 1 minus k square raised to 3 by 2. This d naught cube and this d naught cube cancels, which is equal to 1 minus k square, a square minus b square, a plus b into a minus b. That is our meeting. A square minus b square is equal to a plus b into a minus b. 1 plus k square. Okay. This is 1 minus k square into root 1 minus k square. Isn't it? This is 1 minus k square is 1. Root is half. Therefore, it will be equal to 3 by 2. Okay, this 1 minus k square and this 1 is cancels, or t strength by t solid, which is equal to 1 plus k square by root 1 minus k square. What is k? K is equal to di by d naught. Always the diameter of the inner diameter will be less than the outer diameter. For example, let us take the inner dia as 90 mm, outer dia as 100 mm. Therefore, k will be equal to 0.9. You substitute zero point 0.9. 1 plus zero point 0.9 square by root 1 minus zero point 0.9 square, which will be always what? This is less than 1, which will be greater than 1. Therefore, this term will be greater than 1. Okay, isn't it? Because this 1 plus zero point 0.9 square, denominator is less than, give me a moment. This torsional strength of hollow shaft, the torsional strength of solid shaft, we will calculate 1 plus zero point 0.9 square by root 1 minus zero point 0.9 square, which is always greater than 1. Something 1.81 divided by the thing which is less than 1 should be greater than 1. You calculate and tell me. Therefore, torsional strength of hollow hollow shaft is greater than solid shaft for the given material length and weight. Hope you can understand this. But is there any doubts in this? Simple derivation, but you should see which criteria you should take. Weight is same. So in order to derive that d term, this is what we need to substitute. There is in terms of d. I want everything in terms of one term. So I will express my d also in terms of d naught. So this is what d naught, d will be d naught root 1 minus k square. I am using this weight criteria. Weight of hollow shaft is equal to weight of solid shaft, and then we will be getting finally this is what torsional strength of hollow shaft 1 plus 0.9 square root 1 minus 0.9 square is an example, or generally it is 1 plus k square by root 1 minus k square, isn't it? Torsional strength of hollow to solid shaft is 1 plus k square by root 1 minus square k square, which is greater than 1. So greater than 1 in the sense like this. Torsional strength of hollow shaft, the torsional strength of solid shaft 1 plus k square by root 1 minus k square. This is what we got. It means that it is greater than 1, which means that torsional strength of hollow shaft greater than torsional strength of solid shaft. That's all. Okay, I'll go ahead. Next thing, next comparison. Second, comparison, comparison of of torsional stiffness, torsional stiffness. Have we discussed this torsional stiffness, torsional rigidity? Have we discussed that? The previous class, same convention, power thing I have discussed, rigidity criteria I have discussed, torsional strength I have discussed, strength criteria, torsional strength, T by theta is our torsional rigidity, T by tau is our torsional strength, we have discussed that. That is our strength criteria, shear stress, and then our rigidity criteria in the sense angle of twist. Comparison of torsional stiffness of hollow and solid shaft. Okay, consider the hollow and solid shaft of the same. You should remember that in the examination you should give, the examiner has to give, but generally they will not. If you compare the torsional strength of hollow and solid shaft, you should give for the given same material, for the same length and weight. You should explicitly give that, but sometimes in the question paper they will not give. Then you should remember that consider the hollow and solid shaft with same material, length and weight. In this case also weight is same. When the weight is same, let me write weight of hollow shaft is equal to weight of solid shaft. Shall I take directly from this expression? That is density. I will take from directly from this, since weight of hollow shaft is weight of solid is equal to weight of solid shaft. Can I directly take this expression, or would you like me to solve once again? What shall I do? What shall I do? Would you like me to solve once again, or shall I directly take that the d term directly from this? Yeah, shall I directly take this d? What should I do? Yes. Okay. Shall I directly take, or should I derive it once again?
Take directly, sir.
I will take directly. See, since the weight is same, the same thing comes into picture. That is, weight density is equal to weight per unit volume. Or density into volume is equal to weight. Weight of hollow shaft is equal to weight of solid shaft. Weight is equal to this weight is equal to density into volume. Density is nothing but specific density, which is nothing but rho, into volume is nothing but AH into LH. So volume is area into length. So I will be substituting this. Material is same, so specific weight remains the same for both the materials. Length is also same given in the problem. So area of solid shaft should be equal to area of solid shaft. So when we solve that for the area, and then we will get an expression d is equal to d naught root 1 minus k square. I will take directly this. We know that d is equal to d naught root 1 minus k square. I will call this as 1. Torsional strength, we know that T by J is equal to tau by r is equal to g theta by L, or T by theta is equal to Gj by L is a torsional strength. Okay, torsional stiffness or torsional rigidity. Torque required to produce unit angle of twist. Torsional stiffness of hollow shaft. Ratio of torsional stiffness of hollow shaft to torsional stiffness of solid shaft, which is equal to Gj by L of hollow by Gj by L of solid. Let me write it. Since this G and L are same, material is same, this G and hollow shaft material is also same, solid shaft material is also same, length of hollow shaft is same, length of solid shaft is same. Therefore, torsional strength of hollow shaft by torsional strength of solid shaft, which is nothing but J by hollow by J by solid, which is equal to pi d naught power 4 minus di power 4 by 32 by pi d power 4 by 32, or I can write pi d naught power 4 minus di power 4 by 32 into 32 by pi d power 4, or d naught power 4 minus di power 4 by d power 4, which is equal to d naught power 4, 4 if I take common, 1 minus di by d naught whole power 4 by d power 4, or if I write it like this, d naught power 4 into 1 minus k power 4, the k is always di by d naught, you should remember lesser dia by larger dia. Okay, k is equal to smaller dia by larger dia, k power 4, k power 4 by d power 4, from this equation d naught root is of raised power 4 is equal to 4 by 2, which will be equal to 2 into 1 minus k square, the whole square. This is d naught power 4. Okay, this will cancel, or it will equal to, shall I write this as 1 minus k square into 1 plus k square, okay, divided by 1 minus k square, the whole square. 1 will cancel, therefore it will be equal to torsional stiffness of hollow shaft by torsional stiffness of solid shaft, not torsional stiffness, okay, which is equal to 1 plus k square by 1 minus k square, 1 plus k square by 1 plus k square by 1 minus k square. Wait a minute. Torsional, torsional. You substitute one value there in case of k. Stiffness of hollow shaft by torsional stiffness of solid shaft, which is equal to 1 plus k square by 1 minus k square. Let us say D outer dia as 45 and inner dia as 40. K is equal to di by d naught. Substitute in this term, and what you will get, you tell me. One of the substitute and tell me what you will get. Substitute there. Substitute there. What you will get? What? Tell me what is k first. What is k? K is equal to di 40 by 45. Tell me what is this value? How much? How much?
0.888.
0.888. Therefore, let us write which is equal to 1 plus 0.88 the whole square by 1 minus 0.88 the whole square. What is the value you are getting? Tell me.
7.86.
7.86. Is it 7.86 1 plus 0.88 the whole square by 1 minus 0.88 the whole square? Correct, is that Raghavendra?
Yes, sir.
Give me a moment. Anybody else make the answer? Have you calculated? 1 plus 0.8 how much already?
4.55.
ಅಯ್ಯೋ ಇದನ್ನು ತಪ್ಪು ಮಾಡ್ತೀರಮ್ಮ. 1 plus 0.88 square by 1 minus 0.88 square. 7.86. Hmm. 7.86. Okay. Therefore, torsional strength of hollow shaft by torsional strength of solid shaft is equal to 7.86. Isn't this greater than 1? Therefore, torsional strength of hollow shaft is 7.86 times the torsional strength of solid shaft. Therefore, I can write torsional strength of hollow shaft is greater than torsional strength of solid shaft. This will be always greater than 1. Why? Because we got 7.8, it will be greater than 1. There are instances like weight and other things where this will be less than 1. That is weight of hollow shaft to weight of solid shaft. Some, for example, some 0.5. Okay, 50% of the weight can be reduced by using hollow shaft, something like that. Okay, now let us go to next comparison. Give me a moment. You should not do mistakes in the examination. Concentrate and calculate it. Okay, one more thing. If you are going outside due to Christmas, you should have been informed me, right? If you have separately pinged me or if you have called me and said we are not coming, we are going outside. That is possible. That is already time you could have requested me, sir. Okay, but from Monday onwards we'll complete that another two experiments remaining, and then we will go to machine shop. Machine shop. So the instructors will guide you how to turn and thread cutting and other things. Okay. Comparison of weight of hollow and comparison of weight of hollow and solid shafts. Consider a hollow and solid shaft of same material. It is G is same, rigidity modulus, length LH is equal to LS, and torsional strength. Yes, given consider solid hollow and solid shaft of same material, length, and torsional strength. Okay, and that is torsional strength is T by tau. T by tau of hollow shaft is equal to T by tau of solid shaft. Or I can write T by J is equal to tau by r is equal to g theta by L, or T by tau is equal to j by r, or I can write j by r of hollow should be equal to j by r of solid. J by r for hollow pi d not for 4 pi d for 4 by 32 into r is the maximum radius d naught by 2. Okay, section modulus we should take from the R in the sense section modulus the radial distance from the center to the outermost fiber, which is equal to pi d for 4 by 32 by d by 2. Okay, or d naught power 4 minus di power 4 by 32 into 2 by d naught, which is equal to d power 4 by 32 into 2 by d. This all cancels by 32 could have been also cancelled, but I have written that. Okay, let me write this. R d naught power 4 minus di power 4 by 16 d naught, which is equal to d power d cube by 16, or 16 16 I'll cancel, or d naught power 4 minus di power 4 by d naught, which is equal to d cube. Let us go one step ahead. D naught power 4 minus di power 4 by d naught, which is equal to d cube, right? D naught power 4 minus di power 4 by d naught is equal to d cube. Or I will take uh, okay, I will take d naught power 4 common. D naught power 4 1 minus di by d naught the whole power 4 by d naught is equal to d cube, which is equal to d naught cube into 1 minus k power 4. This d naught and this will cancel. D is equal to d naught root, sorry, d naught 1 minus k power 4 by 1 by 3. Okay. Yes, asked comparison of weight of hollow and solid shaft. Weight of hollow by weight of solid. Weight is rho A L of hollow by rho A L of solid. Rho and L are same. Therefore, I have left with area of hollow shaft by area of solid shaft, which is equal to area is given by pi d naught square minus dA square by 4 by pi d square by 4, which is equal to pi by 4 cancels, which is equal to d naught square minus dA square by 4 into this will be 4 by d square by d square. This 4 also cancels. Sorry, by d square, right? D naught square minus d square by d square. Weight of hollow by weight of solid. If I take d naught square, it is d naught square minus d square by d square. D naught square if I take common, which is equal to 1 minus di by d naught the whole square by d square, which is equal to d naught square into 1 minus k square by d square, which is equal to d is this term, okay, d square d naught square into whole square is 1 minus k power 4 by 2 by 3, which is equal to 1 minus k square 1 minus k square by 1 minus k power 4 raised power 2 by 3. Now weight of hollow shaft by weight of solid shaft, which is equal to 1 minus k square by 1 minus k power 4 raised power 2 by 3. Let us take example, same example, k is equal to 0.88. Tell me what is this? 1 minus 0.88 square divided by 1 minus 0.88 raised power 4 raised power 2 by 3. What is the value of it? You tell me. Is it 0.415? Is it 0.415?
Yes, sir.
0.415. Therefore, weight of hollow shaft by weight of solid shaft is equal to 0.415. Therefore, weight of hollow shaft, this is 0.415 times weight of solid shaft. Therefore, I can say that weight of hollow shaft by weight of hollow shaft is less than 1, or I can write weight of hollow shaft is less than weight of solid shaft. Therefore, for the given material length and torsional strength, weight of hollow shaft is less than weight of solid shaft. This is one of the major advantage. I can reduce the mass, reduce the cost. I can have the material with the outer fiber where the maximum stresses are induced. Okay. Next, this thing. Uh, this is also same for the given material and length, torsional stiffness of the given material length and weight, torsional stiffness of hollow shaft is greater than solid shaft. That is why your propeller shafts are made up of hollow shafts. Okay, one more derivation I'm left with. It is a comparison of power transmitted. Okay, let me try to time now. Okay, shall I continue this in the next class? Shall I stop at this point? We'll solve few problems and then we'll continue with this derivation, that is the comparison. Another 3, 4 problems will solve, and another 8, 10, 12 problems will solve. And this is a very simple problem. These are just models which I can see for you, these two models, Torsion and Buckley. I'll stop at this point. Okay, any doubts if you have, you can ask. Okay, I'll stop at this point.